SciShow Space is supported by Brilliant.org. We've got another discovery to add to the growing list of surprises astronomers have uncovered about the early universe recently. In a paper published last week in the journal Nature, an international group of researchers announced that they'd found a pair of galaxies from the first billion years of the universe. And they're almost impossibly big for their age. The first galaxies started forming a few 100 million years after the Big Bang. And for the most part, we assume they were fairly small, irregularly shaped collections of a few billion stars, similar to modern dwarf galaxies. Those small galaxies would then act as building blocks, merging together over the next billion or so years to form the much larger galaxies we're used to seeing. The problem is, the pair of galaxies the researchers describe in their paper, which is from about 780 million years after the Big Bang, doesn't really fit that description. Looking so far back in time is difficult because everything is really far away and incredibly dim. To study this pair, the team used the ALMA Observatory in Chile to take advantage of an effect called gravitational lensing, which is where the gravitational pull of a large galaxy between us and the object of interest warps that object's light, making it look brighter. Unfortunately, the lensing also heavily distorts the image, so the researchers needed to use computer modeling to calculate things like how far away it is and how much mass it has. Turns out, a lot. They found that the larger of the two galaxies has a mass of gas and dust over 270 billion times the mass of our Sun, about 3 to 5 times as much as the Milky Way. This makes it the most massive object ever detected from the first 950 million years or so of the universe's history. The other galaxy is much smaller, coming in at just 35 billion solar masses, but for its time, it's actually pretty impressive in size too. But both are nothing compared to the amount of dark matter they're embedded in, which the team estimated to be a few trillion solar masses. Dark matter makes up nearly 85% of all the matter in the universe. It doesn't interact with light at all, which is why it's been so hard to figure out what it's made of, but we know it's there based on how its gravitational pull affects the regular matter we can see. While the dark matter around this pair is roughly equivalent to the amount of dark matter in and around our own galaxy, astronomers have found that early galaxies tend to have much less dark matter relative to their size. It would be more like finding a modern galaxy with 10,000 trillion solar masses of dark matter instead of just a few trillion. That's how extreme this is. Altogether, these galaxies and their dark matter almost break the current models astronomers have for early galaxy formation. Like, the math still technically works, but barely. And that's not all. We're also seeing the two galaxies right before they merge. Their centers are as close together as our solar system is to the center of the Milky Way. So this pair of galaxies is super weird, and it'll be interesting to see how scientists use the data from this new discovery in future research on how and when galaxies started forming in the early universe. Closer to home, NASA announced last week that the Opportunity rover has officially made it through the worst of its 8th Martian winter, but a planet-wide dust storm might be on the horizon. Unlike the radioactively powered Curiosity rover, Opportunity relies on solar power to keep running, and sunlight comes at a premium during the winter. Since the rover is in Mars' southern hemisphere, the mission team has to position it on angled ground so its solar panels are tilted north toward the sun. That might not sound like a big deal, but Opportunity's twin Spirit failed to survive their 4th Martian winter back in 2009 because 2 of its wheels broke and it couldn't maneuver itself into a position where it could capture enough light to keep running. And during the very next winter, Opportunity got stuck in one spot for 19 weeks because there were no places within driving distance that could provide the necessary tilt. But it's in a much better location now, inside the western edge of what's known as Endurance Crater, where there's plenty of angled ground. But the tilt of its solar panels isn't the only thing Opportunity has to worry about to get enough light during the winter months. Dust is another main obstacle, both the particles that get kicked up into the thin Martian atmosphere during storms and those that settle on the rover's solar panels. Continent-sized storms happen every year or so, and because there's so little water in the atmosphere, the dust can hang around in the air for weeks. In July 2007, a planet-wide dust storm forced Opportunity to shut down all non-vital systems when the surrounding dust blocked 99% of direct sunlight and it lost 80% of its power output. It took 6 weeks for the rover to get back to work. Mars hasn't had a storm like that since Opportunity's brush with death a decade ago, but the average length of time between those giant storms is 3 Martian years, or 5.5 Earth years. That doesn't necessarily mean you can expect a massive storm every 3 years, but atmospheric scientists aren't sure why it's been so long since the last one. Some think the next one might might happen in 2018 as Mars's orbit takes it closer to both the sun and the solar system's center of gravity. Even if we do get another planet-wide storm this coming year, the mission team is optimistic. Back in the Martian autumn, Opportunity's panels were the second dustiest they'd ever been, but they've gotten much cleaner since that, thanks to some wind. So at most, Opportunity might have to put its exploration on hold for a bit while it waits for more wind and sunlight. Not bad for an almost 14-year-old rover that was only supposed to run for 90 days. Like with that almost impossibly large pair of galaxies, sometimes life in space is all about defying the odds. The main reason we've been able to learn about those galaxies or anything else from the early universe is Hubble's law, which lets you take advantage of the fact that light travels at a constant speed to calculate an ancient galaxy's distance and age. SciShow sponsor Brilliant helped rekindle my understanding of Hubble's law with an interactive lesson in their astronomy unit. So in this first one, you're standing in a cycle path beside a train and you're facing a train that's going perpendicular to you. The train goes along at 40 miles an hour, they leave the station every 10 minutes and travel in the same direction. So how many trains go past in an hour? So 6. And so now you're finally riding your bike at 20 miles an hour in the same direction as the train, so that halves your answer and you have 3. The other way you get more because you're going opposite the direction of the train, so you're gonna see more trains. So 9, I got that right. What a cool way to look at this. If you are biking away from the source of a green light and you pedal quickly enough, like really, you'd have to go really, really fast. What will happen to the light? When I was biking away from the train, I was seeing the trains less frequently. So I would be seeing the waves of the green light less frequently. So the waves would be longer in between. So it would be red light. I got it. So that was a fun one, and I'm going to keep playing it, but I don't want to tell you all the answers, and I don't want you to start seeing when I get them wrong. So you should go check it out though too. And the first 200 people to sign up at brilliant.org/SciShowSpace will get 20% off of their annual subscription and support SciShow Space. So thank you.